You might have heard of the term loops in regards to AI and this new phrase graphs that the creator of OpenClaw has just come out with. And I think it's about time that I sat down and tried to simplify what these things are. As you can see here, we have the simplest loop. This is something that you've probably used within the harness of your AI system that you're using. If you use Codex or Cursor or Claude Code, you are using loops. So if you asked an AI agent to center a button, it's going to try to center that button, execute some code, run some agents, identify where the button is, etc. So it's going to enter into this execution phase, and then it's going to do some sort of check to see if it's actually centered the button. It has a few options here. It can see that the code it's changed has centered the button, or it might open a browser within the harness to check if it actually has visually centered the button that it has been asked to do. It would then check if it is centered. If yes, well, the loop is finished and we can exit. And if no, well, we try to recenter the button again. And that loop will just continue until it feels that there's something it can't do, or it has actually centered the button. Now that's the simplest form of a loop. And I want you to keep that in mind as we kind of like go up the complexity ladder here. And here we have a more complex loop. This is a loop for getting agents to discover GitHub issues and then breaking them down into manageable chunks, writing tests for them and executing them, and then creating a PR for that issue. As you can see here, we try to discover the issue, retrieve the context for the specific files that it needs. It creates a plan, it splits that plan into smaller chunks. It writes tests for those chunks, and then it does the solving or executing phase. And if all the tests that it wrote for this issue pass, then we can create a PR, and then we can go and check for more issues. And as you can see, this had a loop within a larger loop, and that's like where the complexity comes. And you can have these loops within loops and grow this out to be something that is like quite large. And I want you to keep that in mind as we now talk about graph loops. So you might have seen this tweet from Peter Steinberger, who is the creator of OpenClaw, who works at OpenAI. And he's saying, are we still talking loops, or did we shift to graphs yet? And this is like blown up within the AI space. It's 2.6 million views. All a graph is going to be is loops within loops. And that's it. It's just in a more complex structure. So if we have this, let's go through this graph. So we have some sort of orchestrating agent, and the agent asks, what should I do? And we have different branches that it can walk down. The ideal path that we're going to do is we're going to say, hey, check for issues. And that's just this exact loop that we just covered in the complex loop, but it's now here. There are no issues. Well, then what's it going to do? It's going to come back and be like, okay, well, what's the next thing that I can do? It can check for bugs. Well, it can start going through the code base and do a bug kind of sweep, check if it notices anything, if there's any kind of like obvious issues that it can detect, and then it's going to create issues or try to fix those bugs itself. And then it's like, okay, well, I've done that, and now there's no bugs that I can detect as the model. So what can I do now? Well, I can check for missing documentation. If there's no documentation, well, I can come all the way back up here, and what should I do? Oh, I could do market research, and I would have another loop within this node structure for market research. And if I've done extensive market research, then I can come down, I can propose new features. And then this can go on and on and on as much as you want. And this is in itself a loop. It's just a recursive loop because it has to move down one branch, reach an end, come back, move down, come back, move down, and repeat, and constantly be checking if there's more issues or if there's more research that I can do. And this is in itself just a more complex loop, or in computer science, a graph. So yeah, I wanted to explain that and why it's not super complicated, because I think a lot of people are going nuts that this is some massive revelation. But yeah, it's just a glorified complex loop. Thanks for watching, guys. My name's been James, and if you enjoy the content, please like and subscribe. Cheers.